So it's division instead of multiplication. So the k is being divided by 4, but would I still start the same way? What would you start by doing? Anybody? Okay. Subtract 7, multiplying it by 4. We can do either way. All right. It's probably going to save us a step to subtract the 7 first. If I multiplied by 4, I would have had to multiply the 7 by 4, the 15 by 4, which would have worked. So k over 4 equals, what's 15 minus 7?
80.
And then we can do what? Multiply by 4, which gives me k equals 32. All right, so that one, 2 steps. You add or subtract when you multiply or divide. Here, adding 1 extra step. What did we do for warm-up? Combine like terms. So now, check your equation first. Can you combine like terms before you then solve? If I look at number 3, anything there that you can combine?
Negative 2x.
Okay, and what does that combine to make?
3x.
Negative 3x plus 6 equals negative 24. Good. So then what would you do? Subtract 6. Be careful of your sign. Negative 3x, negative 24 minus 6 is what? Negative what? Negative 30. That's, yeah, because those signs can still trick us, right? Now
X equals 10.
X equals 3. How'd you get X equals 3? What was the last step?
No, 10.
10. My fault. 10. Good. X equals 10. Good. Y'all try number 4 on your own. Equals 3. I agree. Okay. Let's take it up another step. Okay. So we did these prior. We are adding on distribution. When I distribute, let's look at number 6 together. What's getting distributed on number 6? I heard it. Negative 3. Okay. Common mistake. What do people distribute on accident? 3. Make sure you take that sign in front of it, because if I took 3 and then I put a subtraction sign there, I'd end up with negative 18 when negative 3 times negative 6 should give me what? Positive 18. Good. Okay, so now we've distributed the step that we added last time, combine like terms. Can you do any of that? Yes. Where?
19x minus 3x.
Which is?
Which is 16x. And 66 minus x is 48. And 48 minus 6 is 3.
You go, girl. Mic drop. All right, 16x equals 48 divided by 16. X equals 3. Okay. Yes? All right. Try number 5 on your own.
Yes.
All right. So, number 5, what'd y'all get?
X equals negative.
It's positive.
A positive.
It's 2.
Oh, yeah.
Okay. Time out. 2 times negative 3x, negative 6x. 2 times negative 4, negative 8.
Then add 8, and you add 8 to the stickers. Oh, yeah, and then you get x.
Don't worry about it. Okay. X equals 2. Let's take it up again. So now, last year, y'all had scenarios similar to this, right? And you looked for a within or between, or if you couldn't find one, what'd you do? Cross multiplied, and you would get 2n equals 35, and you would solve it from there, right? Cross multiply and divide. We're going to do the same thing, but instead of it being a single constant or a single variable, I've got k plus 3, which means that when I multiply 5 times k plus 3, it has to go to the entire thing, not just the k, not just the 3, all of it. How can I multiply it to all of it? Okay, I'm going to use parentheses. Good job. 5 times k plus 3. Would I do the same thing for the 6? Yes. Okay, so now what kind of scenario do you have? What do you need to do next?
You need to
Distribute. We need to multiply. What's 5 times k? What's 5 times 3? 6 times k? And 6 times -7. All right. So now, variables on both sides, constants on both sides. Does it matter where I start right now? No. Right now I can move anything that I want. I can move 5k to 15, 6k with -42. Other people might choose to do different values. But if I'm looking at it, I would choose to start with the 5k. Anybody else think that that 5k looks good to move first?
Yeah.
Why do you think that I would pick the 5k? It's the lesser value, which would leave me with a positive variable. Good. Number 7. All right. So now 15 equals, what's 6k minus 5k?
8k minus 42, you add
57. Good. Should I do the same thing for number 8?
Yeah.
What values would get distributed? The 2, and then 9 would go to n plus 7. Why don't y'all finish that one out for me? Okay, what'd you get? 10?
4.71.
Anybody leave it as a fraction?
Oh, that makes so much sense.
Yeah, no.
No, we didn't do that. We just tried to figure it out.
Negative, right?
Yeah,
Yes, negative.
7.
Negative 75 over 7.
Oh.
Okay, it's always okay. It's always okay to leave it as an improper fraction as long as you've simplified it. And 7 is prime, so you can't simplify it farther. Okay? So now, just a quick discussion before we're going to do 10 and then 9 because 9 is harder than 10. You guys can tell how they're different, right? Yeah. All right, so thinking about the processes that we've just used. When you solve, if you see addition, what do you use to solve it? You see an equation addition, what do you do? Undo it. Subtract. You see multiplication, what do? Divide. What would be the opposite of squaring something?
Square root.
Square root. Good. So if we look at number 10, let's change it a little bit. If I said 4x minus 3 equals 324. Does that look okay to y'all? What would you do?
Add 3.
Add 3.
Divide
Divide by 4. Okay. So you would get 324, and you would divide it by 4, which gives you 81, right?
81 squared.
But now it's not 4x, it's 4x squared, but it's still subtracting 3, it's still multiplying by 4. What's the other thing that's getting squared?
The x.
The x. So if I have this, which you guys just told me to do, right? This is still right. If if the x is the only thing that's squared, can I still deal with this 4? Yeah, divide by 4. So far, any of my steps different? But now I'm here.
Square root.
Square root. Because what's special about 81?
It's the square root of 9.
It's a perfect square. It's 9. It's 9. So all I did at the end was I added that extra step. Instead of it was x, it was x squared.
So you just basically just take out the x and fill in the x.
But look at number 9.
But only
Yikes.
lots of x.
Okay, so in number 10, x was squared, right? In number 9, what's being squared? The whole interior of those parentheses, right? Don't try to get crazy now and distribute an exponent. Don't do it. Don't do it. Because what this is saying is negative 3x minus 3 times negative 3x minus 3. Okay? Which we're not going to until about January. So, what else is happening to that though? Besides that being squared, what else? Distribution of what? The 2. Everything's being multiplied by 2. Can you get rid of the multiplication of 2?
Yeah.
How? By dividing it.
Yeah.
Okay. So far, so good. What's left? Okay. Can I touch anything inside these parentheses while that exponent's still up there? It's like a lock, right? You can't go inside there with that still hanging out. But I can get rid of it. How? Square root. Square root of 9 is 3. And now that I've canceled this out, the only thing that's left is that. It's kind of like if you have that, right? Can you subtract 7 from both sides with it looking like this? No. Why? What's keeping me from subtracting 7? The division of 2, right? Everything's being divided by 2. So before I can even touch any of this, I'd have to multiply by 2. The same thing applies with that exponent. It locked it into place until you get rid of it. So I take the square root. Now all I have to do, add 3. And then what should I do last? Well, x is negative 2, but what should I do last? Divide by negative 3. Bingo. It's like a puzzle, right? You need to figure out at what point you need to do all of this. And I wrote PEMDAS up here because when you solve something, like when you solve, you go this direction, right? But if you're trying to work backwards to solve an equation, have you noticed that you always take care of addition and subtraction first? And then multiplication and division? Then exponents, unless it's blocking something from happening. Okay, so just keep that in mind. All right, this is not on your paper, but I got a couple more scenarios for you. So special cases, I wrote it out to the side, but let's walk through a couple of them. So let's say I had that. What would you do first? You distribute. And that would leave me with what?
4x plus 14.
Good. Anybody notice anything funny about that?
X is not function.
Okay, so if I do this, it cancels here, but it also cancels here. Right? But it leaves me with negative 8 and 14. Does -8 equal 14?
No.
Will it ever equal 14?
No.
Has it ever equaled 14?
No.
No, never.
Yeah, you can't solve this.
No solution. It's on your homework. You'll look at it before you leave, so good question about it. No solution, right? I got down to a statement that was false. That doesn't mean that x is 0. If I tried to plug a 0 in, would it work? No, it would still leave me with -8 equals 14. So no solution and x equals 0 are not the same thing, okay? But here, I've changed one value, but when I distribute this, what? There's something different about that one? Everything is 0 equals 0, right? The 8's will cancel out, the 4x's will cancel out. If I just cancel these out, I'm left with this. But how is -8 equals -8 different from the -8 equals 14? It's infinite solutions because it's true. Good. So think from the perspective, nothing I can plug in here will ever make that work, but everything that I plug in here will make that work, right? So if you get to a true statement, infinite. If it's false, there's none. Okay? Y'all kind of see it. I have some examples up on the board too. Pretty similar. How y'all feel about that? Good? Okay, so there's some practice problems. You are going to work together to solve through them. I'm going to leave these up. Okay? So you guys can have those examples there. But you're going to work through those, and towards the end of class, you have about 12 minutes. Those of you that ride the bus have like an hour and 12 minutes. I'm just kidding. Hopefully it's better. But call me if you need help. All right? Yeah.